So guys, welcome to our channel once again. In today's video on our WAEC Physics Exam Revision Series, we have here just this one question to answer on the topic Derived Quantities and Dimensional Analysis. So guys, in short to stay till the end of this video. Let's go ahead and start with the first question here, which says, which of the following properties of a steel bar can be measured in terms of the dimension of length only? We have A, pressure, B, density, C, weight, D, volume. So guys, the answer to this question is option D, and that's volume. So that's it for this question. Let's go ahead and consider the next question, guys. That's question number 2 here. It says, the dimension of momentum are A, mLt to the power of -1, B, ml to the power of -1 t to the power of -1, c, ml to the power of -1 t, then d, mlt. So guys, let's go ahead and solve this together. Now, in order for us to derive the dimension for momentum, we have to first of all understand the formula for momentum. So we know that momentum is equal to mass times velocity. So with this said, since momentum is mass times velocity, we have to obtain the formula for velocity, knowing that mass is just mass. There is no formula for mass. So we represent mass as m, and then we multiply it by the dimension for velocity, knowing the formula for velocity. So let's take note that velocity is distance over time, right? And the distance has no formula. So go ahead and write L, which is length, since distance is measured in length, over time, which is T, since time has no formula and time is dimensioned as T. So with this, if we multiply this out together, we're going to have m for mass times L for length times t to the power of -1, since t is on the denominator. So that gives us option A here, and that's ml t to the power of -1. So that's the answer to this question. Let's go ahead and consider the next question, guys. That's question number 3 here. It says, which of the following dimensions represents impulse? We have A, mlt to the power of -2, B, ml, C, mlt to the power of -1, D, mlt. So guys, for this, we also have to consider the fact that impulse is force times time. So we have to understand that impulse is force times time. So remember that time has no formula, so that one is set aside already, time, which is t. So we are going to get the formula for force to multiply it by that of time. So for force, we have mass times acceleration. So already mass has no formula, so we take mass down already. Then times acceleration is actually velocity over time. So that's v over time. So recall that time has no formula. So in that case, we are simply going to get the formula for velocity. So let's put down our mass times, the formula for velocity is distance over time. Now distance has no formula, so we have the dimension for distance as L, then over the time. So this is distance over time, and then times this other t here. That's so all together here we have m times L over c squared. So this will give us m L t to the power of negative 2. But let's recall that we had a t here before. So if we multiply this by this t, we're going to cancel out 1 out of the two negative signs. So this will be ml t to the power of negative 1. So that's it for this question. So you see that momentum and impulse actually have the same dimension, and that's mlt to the power of negative 1. So option C is the answer to this question, and that's it for this question, guys. So this is where we'll call it an end to this video. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below and we'll ensure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community where we post major updates on WAEC examination. This will help you a lot even as you prepare for your WAEC examination for the year. So you can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.